All right, and take about 45 more seconds to at least get the website pulled up. And then the awesome thing is once you create a new one, it automatically goes into your Google Drive. So at least I'm pretty sure it does. Like I know I can go back into my recents and here's the test one that I just made.
Well,
all right, once you have that pulled up and you are at least a little bit familiar with it, make sure you look over back on Zoom so we can start our math lesson for today. Let's see, I don't need that. All right, so once I'm done with my lesson, I will make this public so that if you need to see the slides again, you can. I'm recording the lesson right now. When we get through the lesson, you're going to work on 7-2 practice buddy. I think there's like 13 questions. And then if you're not done with Illuminate, you're going to use math time to work on that. And then when you're done with that, then I really like you working on Prodigy because the assignment that I assigned is dealing with what we're dealing with right now in math. So dealing with the fractions. And I've seen like Levi, Mila, Peterson, Ace. I'm trying to think who else I saw on there, but I can see you guys like working on Prodigy. So that's a wonderful, wonderful thing to be doing when you're done. Okay. All right. So let's move into our math lesson for today. Let me turn on the pointer. Oh, the way I'm doing it, I don't have the little slide thing. That's okay. All right, so here is our target for today. I can find common denominators for fractions with unlike denominators, okay? So right now, when I say that word denominator, you should be thinking that that is the bottom number in a fraction, okay? And then these are your I can. So I can create equal fractions using a common denominator. I can use different strategies to find the common denominator. Okay, so I want you to take 2.5 minutes, and you can use Jamboard. That's exactly why I had you pull it up to answer this question. So Sue wants half of a rectangular pan of cornbread. Oh my gosh, I love cornbread. It's so good. Dina wants 1/3 of the same pan of cornbread. How should you cut the cornbread so that each girl gets the same size portion she wants? All right, use Jamboard to show this problem. Just try your best. All right, so Colton, do you have Jamboard pulled up? Or do you want to just do this on your, okay. Do you want to just do it on paper or dry erase board, or do you want to use Jamboard? Okay, that's fine. So on Dino, I should see people. I should see people on Jamboard showing their work. Somebody in the chat asked, do we add or subtract? What do we do? So the question is, if you have one pan, one container with cornbread, and one person wants half, but another person wants a third, how can you cut it? How can you cut the same pan and they get that amount? Okay, if you don't know, it's not a big deal. This is the start of the lesson, but you're not really adding or subtracting. You're just partitioning or dividing up the pan.
Miss Robert?
Yeah. Wait, say it one more time. See that little orange plus sign in the corner down at the bottom? If you press that, it's going to make a new one for you. And then do you see at the top how there's like a little, it says 1 out of 1? If you click over, that's how you can make more slides. And then you can actually use your finger to like write on there. So you could draw like a square or a rectangle and then cut up the pieces or like divide it up. Let's see. So I'm going to bump this back a little bit more. I'm going to give you guys about 40 more seconds just because I know people are getting onto Jamboard for the first time. So just try your best. Where do I go to get the math on Canvas? So I haven't made the math page public yet. So math won't be available just yet, but you should be able to just watch my lesson right now, and then I'll make that public as soon as the lesson is done. I'm just trying not to get people to work ahead. Alrighty, so go ahead and put your eyes back on the Canvas screen if you don't mind, or on the Zoom screen, sorry. Put your eyes back on the Zoom screen, and we'll talk about this problem. Does anybody feel comfortable sharing what they came up with before I show the answer? Does anybody want to share their screen? That's kind of why I thought the Jamboard might be nice, because if you show it, then you could just share your screen and like share your thinking. And if not, it's okay. I know that this is brand new. Okay, Maya is going to be super brave. Maya, I'm going to let you unmute, and then you should be able to share your screen. I'll stop sharing if you feel comfortable sharing yours. All right. So Maya, what is your thought on this? What were you thinking?
Like the half part,
Mm-hmm.
and then asking how I would do it. And something like that.
Okay. Yeah, no, that's totally fine. All right. Thank you for being brave. Anybody else want to share their thinking? What they came up with? And I know, like, as we are drawing things, like you guys, I've been telling you from day one, I hate drawing. I feel like I'm terrible at it. So when we start moving into fraction, there's a lot of people who are like, absolutely not. I'm not doing that. So it's okay if you're not confident. I'm just trying to see if we can get anybody else's thinking. All right, Mila, you are good to share your screen.
I didn't do it on Jamboard, but can I say what I got?
Okay, yeah, we can try to follow that.
So I got one whole from just adding it together. Like when you add it together.
Okay.
That's what
Okay. Anybody else? So notice I'm not saying if anybody's right or wrong. I'm just getting their thinking right now. Anybody else interested in sharing their thinking? Anybody else? Zane? Zane, do you want to share your screen? Do you want to unmute? I tell you what, we handled this pretty well last week, so I'm going to allow it so you guys can unmute, okay? Zane, do you want to go ahead?
Yeah.
Okay. Ooh.
1/2 and then 1/3.
Oh, and then you did 1/3 like of that 1/2, or you're showing both, like the top is 1/2 and then on the side you're showing, okay, so kind of like going side to side, I see 1/2, but going up and down, you're showing 1/3.
Yeah.
Awesome. Okay. Thank you, sir. Jayana, what are you thinking? Jayana, you said you did dry erase board, right?
Wait, we're using the Jamboard? Yeah, but I went back and did it on.
Oh, you went back and did it? Awesome. Okay.
I started drawing. It's not completely done.
That's okay.
I started drawing.
Yeah, so I wanted you to show that math problem on Jamboard.
So
Oh, okay.
I split like one half, and then I added another line, but it would be smaller, like right here.
Mm-hmm.
It's like smaller because like I split it in half because one girl wanted half, and then I made another line which separated it into 3 parts. Well, it's just gonna be smaller. One person's gonna have a smaller portion.
Mm,
If
okay.
that makes.
Okay. Gotcha. All right. So let's see what I came up with. So I will share my screen. Mila redid her answer. Mila, do you want to re-show yours?
Yeah.
Okay, that's fine.
Okay, so I went too fast because I asked my mom a question and it was like the last second, so I went too fast. So I thought I messed up. I was adding, but it was actually supposed to be multiplying on mine. So I got 5, 6.
Okay. 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 All right. So let's look and see. Sharing my screen. Okay. So here's what I came up with. So imagine, okay. Oh, I also want to point out as we start to do these fractions and we're drawing and partitioning and stuff, it's very easy to make a mistake, okay? Because we're humans, we're not robots, we're not computers, we can't be exactly perfect, okay? So you have to sort of imagine that when I cut this down the middle, that this is half, and when I cut it like this is a third, okay? Meaning you have to imagine that these are equal. So I know that I can cut the pan into thirds, into 3 equal parts, and I also know I could cut the pan into 2 equal parts. But the thing is they're sharing the same pan. The problem says they want to cut up the same pan. So how could we do that? So here's what I was thinking. I could divide the pan in half, and then I could also then cut it into thirds. So have you guys ever watched like at a birthday party, like somebody will cut up a cake, and a lot of times they don't just cut it straight down. They'll cut down or like vertical, and then they'll also cut side to side, right? So I'm cutting the same pan. And then kind of like what Jayana was saying, Jayana was like, okay, well, she'll get this half. And then how, like, where would the 1/3 come from? So we know that Sue would get 1/2. So she would get this whole side. And then how would Dina get 1/3? Well, I can look right here. Look, isn't this still 1/3? Wouldn't that be 1 out of the 3 pieces? So 1/3. Okay, so this is going to make more sense as we go along, but I wanted to point out that I can cut it in half going straight down, and then I can cut it side to side. I want you to take a second and look at how many total pieces we have now. How many total pieces do we have now? Yeah, now we have 6 total pieces, okay? So let's watch what happens. All right, we're going to explore this because 2 times 3 is 6, but how does this work? Okay, so here's another example I want you to think about. Tyrone partitioned a rectangle into thirds. Tyrone divided a rectangle into thirds. Sally partitioned a rectangle of the same size into fourths. So guys, if I took this rectangle and I put it on top of this one, they would be the same size. How could you partition a rectangle of the same size so that you see both thirds and fourths? Okay, so let me show you. So do you see how they have now taken this rectangle, they took Tyrone's rectangle and put it on top of Sally's rectangle. And do you see now how I see 1, 2, 3? There's my thirds, 1, 2, 3. But then going up and down, I see 1, 2, 3, 4. So I can see my fourths and I can see my thirds. Now how many pieces is it out of? Because Tyrone's rectangle was out of 3. Hers was out of 4. Now how many pieces is it out of? How many pieces is the rectangle cut into? Either rectangle, it doesn't matter. It's out of 12, right? Do you see that? So we had 3 strips. Let me go back. We had 3. Well, there's 1/3. Well, they're all shaded in, so it's really 3/3. But we want you to see here's 1 row, here's 1 row, here's 1 row. Here's 4 columns. I want to put them on the same rectangle. And when I do that, when I cut it 3 going horizontal and 4 going vertical, that now makes 12 boxes. Okay, now we have a common denominator. So look here. If I want this whole row, because 1 whole row is 4 pieces. So 1/3 of the whole thing is 4 pieces. And then 1/4 of the whole thing is 3 pieces. Okay, so that was our target. If we go all the way back to this first slide, our target for today is I can find common denominators. Meaning I can find a number that they both go into and I can split this up to find common denominators. Okay, I think the more examples that we do, this is going to get a little bit easier. Okay, the rectangle is partitioned into 12 equal parts. Each part is worth 1/12. Okay, all right, find a common denominator for 7/12 and 5/6. Then rename each fraction. So why do we even need a common denominator? Suppose you have half of a pizza and 1/3 of another, and you want to know the total amount of pizza that you have. How would we add these 2 pieces together? So a lot of times this happens, like over the summer, we got together with some of our Chicago family and we bought like 6 pizzas. Well, it's not all the time do you like eat 1 whole pizza and then you move on to the next one. Some people are going to like pick some out of this box and some out of this box. And so at the end, you have just a bunch of pizza left over from different pizzas. So if I've got half of one and 1/3 of another, we can't just say 2 plus 3 is 5 because they're different size pieces. So I could say I have 5 pieces, but that's not the same as half of a pizza. Okay, so let's explore this a little bit. We know the problem is 1/2 plus 1/3. Like I know that I'm trying to add half of a pizza plus 1/3 of a pizza. That's what I'm trying to do. Okay, that does not equal 1/5. Does not equal 1/5. And let me show you. So like this is the 1/5 piece. Okay, that's how big it is. If you look here, comparing it to 1 whole. So if you look, 1/2 plus 1/3, that's almost 1 whole. Is that 1/5? So if you look here, I'm like, if I have my pieces of pizza here plus my pieces of pizza here, if this is on a pan and I want to see how filled up it is, maybe I can show you this another way. I was kind of playing with this morning. So if I have 1/2 of a pizza plus 1/3 of a pizza, is that 1/5? Look at that. Is that 1/5? Look at the sizes. I have 1/2 of my pizza plus 1/3 of my pizza. Does that equal 1/5 of a pizza? If you look at the whole that's filled up. No, it's not even close to that. And that's because you can't just add the denominators because they're different size pieces. Okay? If we look here, I have 1/2 and this is 1/3. Those are different size pieces. Okay? They're different. So I can't just say 1/2 plus 1/3 is 1/5. Those are not equal. Okay? So let's look and see what we have to do in order to add these fractions. Okay? And then you can see that 1/5 is only about 0. So let's look and see what our process is. Okay? I am telling you right now, there are 2 strategies you can pick from. Okay? 2. Good. Some of you guys already know how to add, and so I'm going to really rely on you to help other people who need more help. Okay? There are 2 strategies. So I'm going to show you the first way. Okay? And I personally don't do it by this, but I think for some of you, this is the easiest, most simple way to start out, okay? So the first way is to multiply the denominators to make them the same. So let me show you what I mean. So if down here, so on this first example, half and 1/3, I multiplied 2 and 3 and I got 6. Now I can make new equal fractions and their denominators are both going to be 6. So watch what happens. So I can see that 3/6 is equal to 1/2. Does anybody not understand how these three pieces equal this one piece? Does anybody not see that visually? Now I'm going to show you why that works. Okay? So this works. I'm trying to tell you that these are equal, and this is how that works. Notice up here, I multiplied by 3. If I multiply by 3 on the bottom to get 6, so I'm taking these two numbers from my fractions and I'm multiplying them. 2 times 3 is 6. 1 times 3 is 3. That's how I know these are equal. Okay, what about this one? I'm telling you that 1/3 is equal to 2/6. I can prove it because if I multiply 3 times 2, that is 6. If I multiply 1 times 2, that is 2. So now let's put it all together. Now can we add them together? Now look at it. I've now divided my 1/2 and my 1/3 into 6. Now are these all the same size? Yes. Now I can add them together. 1, 2, 3, 4, 5. 5, 6. Okay, so somebody said we could not add them together yet. So let me back up and really quick make this make sense. So before, I could not say that 1/2 plus 1/3 equals 1/5. So you kind of have to imagine, like we're adding these together. So my amount compared to 1, let me move these down. My amount compared to 1 should be this full. I should be this close to a full-size pizza. Or if I'm looking at the circles, since a lot of times we think of circles, one whole pizza is going to be like this, right? If I've got half and if I've got a third, do you see how full that pizza should be? So right now, yes, these are different size pieces. So I can't just say I have 2 pieces. I can't just say I have 2 out of 2. I can't say I have 2 slices of pizza. That's not what we're dealing with. We're dealing with half of the pizza and a third of the pizza. So how much of a total pizza do I have? I've almost got one whole. Okay. But some people say, oh, 1/2 plus 1/3 is 1/5. It doesn't work like that because these aren't the same size pieces. But here I can prove to you, look how one of these, see how this is 1/5? Oh, it's not going to let me put it on top of here. Okay, so we know that the pizza is this full. So do you see how it takes this many? Oh, I don't want fifths because I'm going to cut them into sixths. So look how many of these makes half. 3/6 makes half. And then with the same size pieces, 2/6 equals 1/3. So all together, it's 5/6. Okay, but I can't just say, let me take these out. I cannot just say that 3 plus 2 is 5. So 1/2 plus 1/3 is 1/5. Or I couldn't even say 1 plus 1 is 2 and 3 plus 2 is 5 because you see how it doesn't take up the same amount. Okay, so all we're doing is we're dividing the pieces into same size pieces. So I can see half is this much, and then a third is this much, Well, now they're the same size. So now I could say there are 5/6 of a pizza left. Just like it wouldn't even be fair if I did this. Because couldn't I cut thirds into 12ths? Isn't this the same amount, this pink and this yellow? But then if I said Emily gets 3 pieces, well, which 3 pieces? Which 3 pieces would she get? Well, that's going to matter because they're different sizes, right? I couldn't just say Colton got 1 piece and Emily got 1 piece, so they got the same. Well, they're different. So I have to make sure that they are the same size pieces before I can add them together. Okay? Okay. I promise the more examples we do, I think this will make more sense. All right, so let's look at this one. Let's say I'm trying to add 2/3 and 1/4. Okay? I want you to think about how close to 1 whole is this? How close to 1 whole? Pretty close to 1 whole, right? We only have this little section that's not filled in. All right? The problem is right now they are different size pieces. So if I go back to my little fraction circles, okay, they are different size pieces. So I'm trying to add was it 2/3? 2/3 and 1/4. So you can see we're really close to 1 whole, but they're different size pieces. So I can't just say 1, 2, 3, 3/10. I can't just say 3/10 because that does not equal 3/10. And I can prove it to you. Oh, 3/10. Does this amount equal this amount? No, absolutely not. So we need to figure out what number can I split these into? What number can I divide these up into to make them equal size pieces? Our common denominator will be 12 because I just did 3 times 4. So now I'm going to divide each of these up into 12ths. Okay? So I can see I've taken all of these and I've split them into 12ths. So before I put the answer up here, somebody tell me what the equal fraction is. What is the equivalent fraction? We could say 2/3 is the same as how many 12ths? Two-thirds is equal to how many 12ths? See a couple people typing in the chat. 8/12ths. So let's see if you're right. So to get from 3 to 12, I have to times by 4. So if I do that on the bottom, I do that to the top. That's how I get 8/12ths. So those are equal. Okay. What about this one? So I didn't need this 1/4. I think I made a mistake right here when I did this. I don't need this one. How many 12ths is 1/4 equal to? How many 12ths is 1/4 equal to? Couple people putting in the chat. 3, 3, good. All right, let's prove it with the math. 4 times 3 is 12. That's how we get the bottom number. Whatever I do to the bottom, I do to the top. That's how I get the equal fraction. Now, can I add them together? Now that I've cut my thirds and my fourth into these same size pieces, now can I add them together? Yes. Okay. And you can see if I showed it another way. So here was our original problem. Now I'm cutting them into 12ths. I'm going to need a lot of 12ths. So first I'm going to have enough to show my thirds. Okay. So that's my thirds. Now I'm going to show my fourths. You guys told me it was 3. There's 3. Do you see how I've taken up the same amount of the circle? The same amount of the whole. Okay. So guys, make sure you're watching the Zoom screen so you can learn how to do this. All right. Oh no. I'm glad Jayana showed me that, so I didn't have to go all the way back into it. All right. Next example. So this is the second way. So the first way that I showed you was that you can multiply the two denominators to get your new common denominator. Okay. The second way is the way that we practiced on Friday. Okay. The second way is to list out the multiples and find the one they have in common. All right.
LCM. What is it and how to find it for beginners? LCM stands for least common multiple, or the lowest common multiple. The LCM is the smallest multiple that is common to two or more numbers.
But they have the same.
Since we're dealing in multiples, it won't be any surprise to know that for this, we need to know our multiplication tables. Let's say we're told to find the LCM of 4 and 6. We're going to list multiples of both these numbers, and we're looking for the smallest number that occurs in both lists, that's common to both lists, and that's the LCM. Note down 4 or 5 multiples for each number. Multiples of 4, and just list them in a line. 4, 8, 12, 16, 20, 24. And then list some multiples of 6. 6, 12, 18, 24. I see that 12 and 24 crop up in both listings, so they're both common multiples. But the LCM means the lowest or least common multiple, and the smallest number in both lists is 12.
Okay, so I'm going to stop right here just because we did really do a lot of this on Friday, okay? And I want to point out that we could choose 24, right? We could, like, whatever number we pick, we could do 4 times 6 is 24, and we could do 6 times 4 is 24. But it is smart to use the least common multiple, the one that is the smallest, okay? And you don't have to understand that right now, but just know that going forward, it's smart to use the least common multiple, okay? So let's look at some examples. So right now I see I have 2/3 and 1/5, okay? 2/3 and 1/5. List the multiples of 3 and 5, then find the smallest one they have in common. So I've listed out my 3s. Now I'm going to list out my 5s. Oh, stop. You can stop at 15 because they both go evenly into 15. So my new denominator for both of these will be 15. Okay? So here's what we're going to try to do. We're going to try to take 2/3 and we're going to split them up into 15ths. 15ths. So keep in mind the pieces are going to get pretty small because when we had what was it, 1/12? Look how small 1/12 is, right? So if I have to cut it up even more, it's going to be even smaller than that, okay? So how do I do that? How do I get from 3 to 15? I times by 5. What I do to the bottom, I have to do to the top. And then how do I get from 5 to 15? I times by 3. Whatever I do to the bottom, I do to the top. Now, can we add these together? Yes, because they are the same size pieces. So if I have 10 and I have 3, that would be 13 15ths. Okay? Sort of making sense, I hope. Okay, all right, let's look at another one. So this is the second strategy. You list the multiples, and then you find the least common denominator, or the least common multiple. Okay, so we're going to list out our 4s. We're going to list out our 6s. Oh, I can stop because they both go into 12 evenly. So in the video, they listed out 6, 12, 18, 24, blah, blah, blah. You don't need to do all that, right? I always list the smaller one first, and then when I list the bigger one, as soon as I get to that number, I can stop, okay? So our new denominator is going to be 12. Our new denominator is going to be 12. How do you get from 4 to 12? You times by 3. Whatever you do to the bottom, you do to the top. Look, I made a mistake. That should actually be what? Instead of 9, that should be what? Anybody?
6.
Yeah, that should be 6. So I was just obviously going too quickly. So that should be 6 twelfths. To get to 12 from 6, it's 6 times 2. So what I do to the bottom, I do to the top. Now can I add them together? Yes, because they are the same size pieces. These 6 plus these 4 equals 10. 10 twelfths. And if you think about it, 10 twelfths is really close to being one whole. Okay? All right, this was just another, like, just so you could see, like, listing out the multiples so that you can see that you list them until you find the one that they have in common. And then I thought this was really interesting so you could see that 2, 3, 4, 6, and 8 all share multiples. 2, 3, 6, 4, and 8 all share multiples. They all go into 24, which I thought was kind of interesting. Okay? All right, so this is just another way to look at it. This was that original problem that I put on there that you had no idea how to do. So if you wanted to find a common denominator for 12 and 6, you could multiply them together. And then if you look down here, they're showing you how they went from 7 twelfths to 42 72seconds. But do you see how now you're working with really big numbers? That's why I kind of recommend not using that first strategy. It's not always the best strategy to multiply the two together because you get big numbers. Okay? All right, so let's look at this one. So this is strategy number 2. Think of a number that is a multiple of the other. So 5/6. If I multiplied by 2 on the top and the bottom, that would be 10 twelfths. Well, 7 out of 12 is already 12. Does that make sense? I don't feel like I did this one really well. So let's say I wanted to add these together. Let me just refresh this. So, okay, this one is already twelfths. Okay, there's 7 twelfths. And then the other one was in sixth, like this, right? Was it 1/6? No, 5/6. Okay, well, I'll put them here. 1, 2, oh, I'm not going to be able to show that. 1, 2, 3, 4, 5. Okay. I can't just say that I have 5 pieces here plus 7 pieces here because they're different size pieces. But if I break these apart, see how this is 1, 2. So now I can take this away. This one's 1, 2. Now I've replaced this one. Replace this one. This one. Replace this one. Replace this one. And then replace this one and this one. Now, do you see how they're the same size pieces? So what they're showing on this one is that we took 5/6 and we made it 10 twelfths. 5/6 is now 10 twelfths. Now I can add them together. 7 twelfths was already out of 12ths, so I don't have to do anything with that one. Okay. Here's another thing to look at. So I don't know, I guess I didn't finish this slide. Oh, no, this was showing you exactly what I just said. 7 twelfths is already equal to 7 twelfths, so now I just need to change this one. Okay. All right, I'm going to set a 2.5 minute timer, and I want you to work on, actually, hold on. I think I wanted this next slide instead. Okay, I'm going to set a 5-minute timer, and I want you to work on these. Let me actually say this. If you think you're ready for the quick check, like if this is making total sense, like you think you got it, you don't need me, you're ready for the practice buddy, let me correct myself, then I want you to go ahead and start the practice buddy on Pearson, okay? If you think you're going to get these wrong, then I want you to stay right where we're at. I'll set the timer, and then I want you to work on them right here, and then I'll show you the answers. Okay, so I will go ahead and make math public.
a question.
Yeah.
Do you mean like the pre-thing?
That should have been done this morning. So if you didn't do that, then don't worry about it. I want you to do the 7-2 practice, buddy. And I'm making it right now.
Okay.
Yep, on Savas. Okay, so if you think you're ready, you can, mute Zoom or whatever. Yep, on Savas. If you're not ready, then what I want you to do right now is I want you to do these problems. I'm going to go ahead and set the timer. So on Jamboard, if it were me, I would be doing this on Jamboard. Okay, that way if I have a question, you can just share your screen and I can help you. So right now, I want you to find the new denominator that they both go into, and I want you to make equal fractions. New denominator, equal fractions. Colton, are you doing these on Jamboard or are you going to do them on Zoom? Or Jamboard or, Jamboard or on your dry erase board? Do you want to come up here and do them? You think you got it by yourself? Let's do breakout 1. Hi guys, I was just pulling you in here to see, was this making sense or do we need help with this? How's it going? Are you confused? Making sense? Do you want me to share the answers and then you can check and see what you have, or are we just like completely lost? Hold on, I'm going to try to change this so that I can plug into